Hello everyone, in this session we will talk about how to implement Retrieval Augmented Generation using Keras NLP by integrating it with LangChain and HuggingFace. The script for LangChain is similar to the one we used for the Llama index in the previous video. You can find the link to the video in the top right corner of this LangChain video. For the implementation, we are using a language model, that is LLM, from Keras NLP. We integrate this LLM with LangChain using its LLM base class. The LLM base class allows us to create custom LLMs. This custom model can be an API, a model from Keras NLP like the one we are using, or even a local model. To load and process data, we will use different functionalities of LangChain. To generate vector embeddings, we will use model from HuggingFace. The necessary packages and their versions are as shown on the screen. Next, we will import all the required packages as shown on the screen. We define an LLM model from Keras NLP. In this case, it's GPT-2 large model. We store this model in a variable called GPT-2. We then override the base class LLM and create a new class called GPT-2 LLM. The number of output variable determines how many tokens we want the LLM to generate. You can change this number or add another parameters as required. The LLM type is a property of the base LLM class that we override to return information about the LLM. This can also be customized based on your needs. The call method is used when the GPT-2 LLM class is called to generate a response. In this method, we use the GPT-2 model from Keras NLP and its generate method to create and return the output. I have not tried stream method, but it can be used if you want streaming responses. Next, I instantiate an object of the GPT-2 LLM class without specifying an LLM model name, as we are directly using the GPT-2 object in the call and the stream methods. As mentioned earlier, we also use an embedding model from HuggingFace. The text splitter is used to break the text into chunks of 4096 characters. This is necessary because most of the LLMs require the input text to be a certain size. And if you exceed that size, it will cause an error. The text splitter helps us divide the data into appropriate chunks before sending it to the LLM. The directory loader function is used to load data from a specific directory in a certain file format. The data it loads is in the form of documents object. Here I read the text from a file called sentences.txt and split the content by sentences. Why I am doing this? Because I want each sentence to be treated as an individual document. Then I convert the split content into document object as required by LangChain and split the content into the specific chunk size. We use Faz as a vector store to store the vector embeddings. Here we are generating vector embeddings using the split documents and the embedding model from HuggingFace. We are storing all these details in an index object, which is then saved to a local path using the command as shown on the screen. This command is useful when you want to load a Faz index from a local path. If you have generated and saved the index from another script or location, use this code to load it with the specified embedding model. Ensure that the embedding model is the same used to generate the embeddings. Finally, we use retrieval-QA from LangChain to define a chain which includes our LLM class, chain type, and retriever, which is Faz index in our case. There are three types of chain underscore type, and based on our requirement, we are using stuff type. At last, we are using invoke method to ask queries and generate answers. That's it for the day. Thank you everyone for watching this video.